All right, wrapping up section 4, a few more ideas here. So using trig identities to find ratios. So here we're given the sine of the angle is through the ratio 3/5, and we know tangent's negative. We don't know what tangent is yet. And we're supposed to find the remaining 5 trig ratios. What I'll do to approach this is I'll kind of use a combination of making a triangle and making sure we construct it correctly. And this is use trig identities, so we'll try to use some of those too. Now, I'm not going to tell you that you have to use trig identities all over the place or something like that. I want you doing kind of whatever gets the job done. Sometimes trig identities, you might see some shortcuts you may not have tried had you not been forced to try trig identities. So try to use trig identities in your homework as much as you can to see if you can find some shortcuts that will help you out later. So enough about that. We're going to get a triangle with an opposite side of 3, a hypotenuse of 5. And if you know where that's heading, that's going to give you a 4 for your adjacent side. But we can figure that out with the Pythagorean theorem. Tangent's got to be negative. So we've got a sine that's positive. Sine's positive in the first 2 quadrants. You've got a tangent that's negative. Tangent's negative in these 2 quadrants. So this has got to be quadrant 2. Which really, the only thing that really is important about that is when I set my triangle up, I set it up so the angle would be in the second quadrant. Think about this being the unit circle. That would be second quadrant. So 3 is the opposite side. 5 is the hypotenuse. And that's checking out. The y is positive, hypotenuse is positive. If you did Pythagorean theorem, the hypotenuse squared would have to equal the short side squared plus the other leg we don't know squared. And you may not need to do all this, but I'm just showing you just in case. 25 equals 9 plus x squared, so 16 would equal x squared. So x would have to be 4. And technically, I guess this is probably a good way to talk about this. X could be plus or minus 4. And since it's in the second quadrant, that does need to be negative 4. So just make sure however you get there, you do put negative 4. So we should have enough now between using the triangle and using identities when we need to. We should be able to get everything else. So let's go with cosine next. So cosine would be negative 4 over 5, so negative 4/5. Tangent would be opposite over adjacent, so 3/4, negative 3/4. I found cosecant already, so let's find secant. Secant's going to be the opposite of cosine, so negative 5/4. And finally, cotangent, which is going to be the opposite of tangent, so negative 4/3. So the triangle really was the way to go, I think, for this one. We could have used some fancy identities, but in a way we did. We flipped over some of the original functions to get the co-functions. And that's really any way you can get there. When you start seeing more square roots show up in these problems, sometimes some of your Pythagorean triple or Pythagorean ratios, things like that, that kind of helps you solve it easier through algebra. But I'll leave it up to y'all to practice and see what works best for you. All right, let's practice some function composition using trig functions here. So I've got the f function, which is sine, g function is cosine. And this is f times g. I'll try to make sure that I make a note about whether it's f of g or f times g on assessment, because sometimes it's hard to read. This one is times. So f times g of theta. And I've given you the theta is going to be 60 degrees. So I'm going to start with this idea. And again, it kind of works like distributive property. You can say f of theta times g of theta. That's another way to look at f times g of theta. And we know that theta is 60, and we know that f is sine. So I'm going to go ahead and say sine of 60 times cosine of 60. And here's where recalling the values from your unit circle is really important. Sine of 60, hopefully we can quickly kind of think about what that triangle looks like. That's square root of 3 over 2. Cosine of 60, that's going to be the adjacent side. That's going to be a half. So you're going to get square root of 3 over 4.